Hello, hi everyone. I'm Usman, and we're gonna continue off today with our lecture that we were studying. We have been studying in the past, I think, 1 week, which is the topic of functions and graphs. All right, so we've pretty much completed it. We started off algebra from expressions, and then moving on to equations, and then we did inequalities, we solved simultaneous equations, right? And then we moved on finally to the topic of functions. So yeah, functions have been going in the past class. We've learned pretty much everything that we needed to learn. We learned what was we learned what's an inverse function. We learned how to ask for um, how to find out the value of composite functions, how to solve different type of equations. So yeah, now what we're gonna do is we're gonna move on to yeah, we're gonna move on to another topic, which is graph of functions. Okay, so graph of functions pretty basic when it comes to O level specifically. It doesn't have a lot of stuff in it because it's pretty simple, right? So today we're going to study a little bit about graphs, how to plot them, right? And then so there must be some common graphs that examiners do ask in the exams. Okay, so I'm going to tell you those. Okay, and in case you cannot find out the graphs of different type of functions, so yeah, in case you cannot find out different type of graphs, um, um, there I'm gonna teach you a simple way of how to plot them. Okay, so that would eventually be pretty easy for you to understand and grasp the concept. All right, now let's move on to different types of graph, right? So let's say how to plot a graph. First, let's just understand that. Okay, so there are different type of equations. When it comes to functions, there are different type of functions, right? There are straight lines. When we plot a graph, so there's a rough catch. Okay, so when you plot a graph, the line doesn't necessarily have to be a straight line. Okay, some lines are straight, right? They're called linear graphs, right? Linear graphs are graphs which in the equation it does not have anything except for a power of 1 over any variable, right? Let me give you an example. So if a function is fx equals to 2x minus 4. Okay, so here x is the variable, right? And it has nothing but a power of 1 over it. That means it's going to be a straight line. So different type of equations, let's say 3x, it's a straight line graph, right? Now that is how you identify whether the graph would be a straight line graph or a curve, or what kind of curve. So there are different type of curves, right? So there are a lot of things which are not a part of your syllabus. However, their graphs, like the shape of their graphs, are not. Basically sketching them is also not a part of your syllabus. However, their shapes, you should be aware with the shapes of those graphs. So I'm going to teach you that today as well. So let's begin with how to plot different type of graphs, right? So there, I was telling you that there are straight line graphs, like straight lines being plotted on the graph. There could be curves on the graph, right? And there could be exponentials on the graph, right? And then there could be um what, a cubic graph. There could be a cubic graph. Okay, so there could be any different type of graph. So I'm going to teach you different ways of plotting them as well. So now let's come to um come on to the question of how to plot them, right? So right now I'm going to share this image of a graph. Okay, so yes, that's it. Now the first step is in plotting the graph is to identify the axis. All right, so this one is our x-axis, right? This one is our x-axis, right? This is positive x-axis. Why I'm saying positive x-axis? Because 1 2 3 4 5 6 7 8, and then it goes on to 9 10 11 12, but it moves to the positive side of x, right? Similarly, this point is called origin. This point is called origin. It's very important to know the names, because sometimes they don't even ask you what the value is. It's just 0 comma 0, right? So it's 0 comma 0, right? That's why it's called origin. Now this is the side which is called negative x-axis, right? So why negative x-axis? Because it's moving towards the negative side, so -1, -2, and then further on onto the negative sides. Now here it's a positive y-axis, okay, right? And here it's a negative y-axis, similar concept as the x-axis, okay. Now the important thing is to know the scale of the graph. So what does I mean when I say that it's important to know the scale of the graph? So what's the scale of the graph? Scale of the graph means what does it represent? Okay, so one box here, let's say it's not a big graph, so it's a pretty small graph. So one box here represents 1%, 1 centimeter. So we say that 1 centimeter equals to 1 unit, because in, let's say that this is 1 centimeter, right? So it's representing one unit on the graph as well. So that is why we say 1 centimeter on one equals to 1 unit on both axes, both axes, right? So what does I mean by that? If let's say for some matter of time it's like this, right? There could be graphs like this as well. So here's one one let's say 1 2 3 and so on, and similarly -1 -2 and so on. But on the y-axis it's like 2 4 and 6, so it's going to be this, it's going to be different. So it's going to be 2 centimeters, um, maybe, sorry, 1 centimeter equals to 2 units on y-axis, right? And then 1 centimeter equals to 1 unit on x-axis. So that's how you write the scale of the graph at the top of the page, because if you do not write that, you're going to miss out one point. Okay, so that's very important. So this scale is very 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 important, because it's marked around 1.5 or 2 marks for the whole graph. All right. So do you understand this? I hope it's clear. So, if at any point in time you do not understand anything, just feel free to ask me on the chat, and I'll be there to answer you. All right. Now, let's find out an equation. Okay. So let's say that we are given an equation of 5x minus 7. All right, so we start off with a pretty basic equation, and then we're going to move to the quadratic equation as well. So let's say our function states that fx equals to 5x minus 7. All right, so what are we going to do? So like I told you in the classes earlier, that fx represents y. So the equation would be y equals to 5x minus 7. All right, so what are we going to do? We're going to draw a table like this. Okay, yeah, like this. Now there's going to be values of x, and then there's going to be a value of y. Okay, so we're going to start, the basic practice is to start from -3 and move to 3. Okay, now -3, -2, -1, and then so on. It could be 0, it could be 1, it could be 2, and then 3. Okay, so we're going to plug in each of the values of x and find out the find out the corresponding values of y. Okay, so if we plot in -3, it's going to be 5 times -3, which is -15 minus 7. Okay, so -3 minus -15 minus 7, it becomes -22, right? So it becomes -22. Now -2 times 5, -2 times 5 becomes -10, -10 minus 7, so it becomes -17. Okay, now -5, 9, -5 minus 7, so it becomes -12, right? And then if I plot on 0, it's going to become -7, right? And then on 1, it's going to become -2, and then on 2, it's going to become 10, 10 minus 7, 3, right? And then on 3 is going to become 15, 15 minus 7, it's going to become 8, right? So here's 8. Now we're going to have to plot this. Okay, but as you can see, my graph, I just copied it from the internet, so it's not really appropriate to this equation. So let me just find another one which could work. Okay, so yeah, I'm gonna take a blank one like this. Okay, so this is a blank graph. Okay, now I'm gonna label the axes according to my own will. So 1, 2, 3, 4. So here's an approximately half of the graph, right? So let's draw a line over it. So this is my y-axis, and now I'm gonna plot an x-axis line. So this is going to be my x-axis. Okay, now what I'm gonna do is, because the value of y is a lot, right? So I'm gonna label, like, this is 1. Let's say that this is 1, this is 2. Okay, so after every 2, I'm gonna plot 1. So this is 3. Now on the negative x-axis is gonna be -1, negative -2. Okay, and then -3, and then -4. So I don't need -4, so let's just leave it here. And now on the y-axis, I'm gonna do -1, -2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So I'm gonna go till -12. Okay, so I might need to shift it a little bit, so let's just shift it upwards till here maybe. Okay, so if we do not shift it, let's say if we do not shift it and we just change the labels, we say that it's gonna move. Okay, yeah, let's say that it's not -1, it's -2, and then this is -4, -6, -8, right? And then -8, -10, -12, right? And then -14, -14, -16, right? So -16, -18, -20, right? So -22, -24, right? So what's the scale is gonna be? So the scale is gonna be, I'm taking two units on 1 centimeter. Okay, so on y-axis, what I'm doing is I'm taking 1 centimeter. 1 centimeter equals to 2 units. Okay, and then on the x-axis, what I'm doing is I'm gonna use the same. So it's gonna be 2, 4, and then 8, and maybe 10, so I don't need any value above 8, so that's fine. Right, now I'm gonna plot it. So let's find the coordinates. So on -3 it's going to be -22, right? So on -3 I'm gonna have to plot -22. So I'm gonna see -3 and then move down onto -22 and leave a point over here. Okay, now I have to plot negative for -2, x equals -2. I have -17, right? So -18 is right here. -18 is right here. Okay, so -18, and somewhere between -17 and -16 and -17, here's the line, here's the plot. Okay, now on -1 I have -12, so on -1 I'm going to move down and point my mark on -12, right? And then on 0 I have -7, which is right here. Okay, and now on 1 I have -2, which is right here, and then on 2 I have 3, which is right here. Okay, and then on 3 I have 8, which is right here, right? So now what I'm going to do is I'm going to make a straight line over it. Yeah, just like that. Yeah, just like that. Okay, so that's going to be a straight line. So this line, like, I'm just going to draw this line over here because this line isn't exactly what I want it to be. So let me just draw it with a free hand. Okay, so it's gonna go like this. Like this. Okay, so this is what the essential gist of the line is going to be. So this is a straight line, right? So this is how you plot a line. Now you see this is a straight line, right? So this is what comes from an equation y equals to 5x minus 7. All right. Now that is how you're going to draw up a graph, right? Now let's say we do not have a straight line equation. Let's say that we have an equation which is a quadratic equation. All right, so let's find a quadratic equation. All right, so I have an quadratic equation which is, okay, so x square minus 5x, right? So our next equation is this, x square minus 5x plus 6. Okay, yeah. Now fx equals to x square minus 5x plus 6. All right, so now what would be the task? What are we going to do? Right, we're going to use the same thing, right? um like this. Okay, so now here are two ways of doing this. Okay, in order to plot a quadratic graph, what you need to do, you need to first convert it into, there are two ways. Okay, so first you need to convert it into a form a x minus h whole square plus k. Okay, so this is a general form of the quadratic equation which you need to convert your equation into. Okay, so how are we going to convert this form of quadratic equation into this form of quadratic equation? So it's pretty simple, right? So we learned a formula in our back in the days. So it's pretty simple formula. It was a plus b whole square equals to a square plus 2ab plus b square. Right, these are the identities that we learned. So a similar identity of this was a minus b whole square equals to a square minus 2ab plus b square. Right, so if our equation is somewhat like this, x square minus 5x plus 6, so now it's easier for us to convert it into this form. Right, so how are we going to convert it into this form? Right, we have the extended form, but we need a shorter form for this. Okay, so now what we're going to do, we are going to work on factorizing it into this form. Right, so let's say that our first expression is x squared, so we take x and whole square. Right, now the middle term is negative, so negative 2 times the first term is x. Right, so now tell me what would be the second term in such a way that it will multiply by 2 to form 5. So what's the second term which will multiply by 2 to form 5? Right, so the second term would be 5 divided by 2. So if I have 5 divided by 2, right, so 2 is going to cancel out with 2, so I'm going to be left with 5. So it's going to be exactly the same equation again. Right, but now I have this value of b. Right, so I need, according to formula, I need b square. Right, to close it up I need b square, so it's going to be 5 divided by 2 whole square. Now you see this is an addition to the already existing equation. Now because this is an addition, I made it myself, so I'm going to subtract it as well. So it's going to be 5 divided by 2 whole square. Right, now I'm going to continue the rest of the equation, which is plus 6. From here till here, this forms the exact formula that I wanted. A square minus 2ab plus b square. Now I can close it down. So if I close it down, it's going to be x minus 5 divided by 2 square. Right, and then I'm going to continue solving this. So minus 25 divided by 4. Right, 25, how 25 upon 4? So 5 square is 25 and 2 square is 4. Right, so it's going to be 25 divided by 4 plus 6. Now let's solve these two. Okay, so if I have 25 divided by 4 plus 6, I can write it down as 25 plus 24 upon 4. Right, so 25 plus 4 upon 4 is 49. Right, 49 divided by 4. Okay, so it could be written as x minus 5 divided by 2 whole square minus 49 divided by 4. So you must be wondering, why did I go to the hassle of finding out this form? Right, what's so special in this form? So you see, a quadratic equation when drawn is a curve. Right, so there's a very important point in a curve which is known as the turning point. Right, with this form I can get the turning point like this. Okay, so how am I going to get the turning point? So I need to know where the graph actually turned. Okay, so I need to know the turning point of the graph. Right, so how am I going to find this? So I equate the x minus whatever the term is, so I'm equate this equals to 0. So x minus 5 over 2 equals to 0. So what's the value of x? X is going to be 5 over 2. Right, which is 2.5, which is 2.5. Okay, now, or you can write it at as x equals to 2.5. Right, and now what's going to be the y? The corresponding y would be this value. Okay, so it's going to be y equals to negative 49 divided by 4. So 49 divided by 4 is what? 49 divided by 4 is 12.25. Okay, so it's going to be y equals to negative 12.25. Right, so I have now successfully found out the coordinates of my turning point. So it's going to be 2.5 comma negative 12.25. Okay, now what I'm gonna do, I'm gonna because I have these two points. Now from my equation, right, I can find out y-intercept. Now what's y-intercept? Y-intercept is a point. Y-intercept is a point where our x is equals to 0. So y-intercept is a point on the graph where the line cuts the y-axis. So this point right here is called a y-intercept, and this point right here is called an x-intercept. Okay, so there are two values of x-intercept and one value of y-intercept. So if we're going to place our x equals to 0, so the equation is y equals to x square minus 5x plus 6. Now if we're gonna place 0 over here, so y is gonna be 6. So I've got one other point, so it's 0, it's 0 comma 6, right? Now if I solve this equation, right, I can get my x-intercepts, right? So how I'm gonna do that, I will take y equals to 0. So x-intercept is a point where x is equals to 0, right? So these 2 points, right? Now what I'm gonna do is I'm gonna place y equals to, so this is the equation, y equals to x square plus, sorry, y equals to x square minus 5x plus 6, right? So it's equals to 0. Now I'm gonna solve this using quadratic formula, which was, what's the quadratic formula? I think we've been learning this for a while now. So it's gonna be, hold on a second. So now I'm going to tell you the quadratic formula directly, which is x equals to negative b plus minus under root b square minus 4ac divided by 2a. All right, so now what's the value of b, a, and c? So value of the number which is associated with x square is a, right? And then this value which is associated with just x is b, and the value which does not have an x with it is solved c. So now just place it into the formula. So negative b means negative times, what's the value of b, which is negative 5, so negative 5, right, plus minus under root, now what's b squared, so negative 5 squared minus 4 times what's the value of a, value of a is 1, what's the value of 6, the value of 6 is, the value of c is 6. All right, now it's going to be what, divided by 2 times 1. Okay, so it's going to be 5, right, plus minus, this is going to be 25 minus 24, right, so it's going to be 2. So one value is 5 plus minus under root, this is going to be 25 minus 24, which would give us 1. So under root 1 is 1, right, upon 2, right? So one value we get as x equals to 5 plus 1 divided by 2. So one value is 6 divided by 2, which is 3. So x equals to 3, right? And the other value is x equals to 5 minus 1 divided by 2 equals to 5 minus 1 equals to 4. 4 divided by 2, which is 2, right? So one coordinate is going to be 3 comma 0, and the other coordinate is going to be 2 comma 0. All right, so this is how now we have our some of the points, right? So now what we're going to do is we're going to take this graph, I think I have it copied. Now I have some points over here. Okay, So I have the turning point, which is negative 2.5 comma 12 point negative 12.25, right? So I'm gonna do one thing. I'm gonna draw some x's over here. Okay, so right, this is my y-axis, and this is going to be my, yeah, I hope that this is all visible to you guys, right? So this is gonna be my x-axis. Okay, now let's just label it. Okay, so this is gonna be negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, negative 11, and then negative 12, right? And then negative 13, right? And then from here it's going to be 1, 2, 3, and then 4, 5, 6, right? On the positive y-axis is going to be 1, 2, 3, right? So on 0 comma 0 comma 6, so I'm gonna need till 6, 4, 5, and then 6. Okay, so now let's just plot them. So one value I have is 0 comma 6. Okay, so I place a pointer over 0 comma 6, and then the other value which I have is 3 comma 0 and 2 comma 0. So 2 comma 0 is this one, and 3 comma 0 is this one. Okay, now maybe what I should have done is I should have left some spaces between them. So let's say that this is 1, this is 1, right? On x-axis this is 2, and then this is 3. So I have some space between them. Okay, so let's say that, right, so this is 1, this is 2, this one is 2, okay, and then this one is 3. Okay, so this is 1, right? So it's 2 comma 2, 0 comma 2, and then this is 0 comma 3. So I have 2 pointers right here, and now I need the turning point. So what's the turning point? Is 2 comma 2.5 comma negative 12.25. So 2.5 is this line right here, which is between 2 and 3, right? And it goes down to 12.25. So this is somewhat what my, this is what my, ideally what my graph should look like, right? I hope this is clear to all of you. If you guys have any problems, then feel free to ask me right now. Do you all understand this? Okay, so this is functions. All right, this is a topic of functions. So functions covers a number of topics. So we've learned from linear algebra, we've learned how to solve the simultaneous equations and other things, and now this is one of the major topics of functions, which is graph of a function. All right, so it is one of the mostly asked topic in GCSE exams. Okay, so they'll ask you to plot a graph, right? So that's where these skills are needed. Do you understand this? So somebody asked me this question, that is why I'm explaining it to them, right? So I hope this is clear to all of you. And she is 6. Okay, Now I've drawn the exact same graph on a visualizer. Do you know when to set equals to 0? Okay, so from, I do not understand exactly from what you're asking. So this is the exact graph of what I've drawn, but obviously I'm drawing it freehand, so it's going to take a lot of practice because I'm drawing it at computer, so it's not that easy. But once you draw it with a pencil it or pen, it's going to be very easy for you. So you see this point right here, this was 3. Okay, so now this is 2. So our points came in as 3 comma 0, right, and then 2 comma 0, right, the turning point, which was, okay, so and then these were some of the points, 6 comma 0, 0 comma 6, right. So this is how we're gonna draw the curve. So I hope that this is pretty clear to all of you, right. So now how do we know when to put 0? All right, so there are two conditions when we put 0. There is one to find out the y-intercept, and then there's one to find out the x-intercept, right. So we put x equals to 0 when we need to find out the y-intercept. Y-intercept is a point where the graph cuts the y-axis. Okay, so this is going to be our y-intercept of this graph, right. And x-intercept is a point where on the graph it's cut the x-axis, right. So for x-axis we're gonna put y equals to 0, right. In the whole equation we're gonna put y equals to 0, just like this. Okay, and then we're gonna use the quadratic equation to solve this. So we're gonna be getting two values. So one value is for this point, one value is for this point, right. So this is how a quadratic graph is drawn. I hope that this is clear to all of you. Is there any question? Right, so I don't see any questions, so that means it's probably okay. So is there any question I asked? So I think everything's clear to all of you. So right now I'm gonna leave you off to a, okay, so what I'm gonna do is I'm gonna give you guys a graph. Okay, give you guys a sheet for the graph. Okay, this is a very important sheet. Okay, there are some of the graphs, some of the shapes of the graph, right. So here's a sheet. Okay, so now if I have a graph like this, if I have an equation like y equals to k divided by x square. So what my graph is going to look like, so my graph is going to look like this. Doesn't matter what the value of k is, the shape is going to be this. Okay, so this is one of the most asked question. Yeah, you should, that's it's important. Okay, so this is one of the most asked questions. So they just give you an equation. So in the terms it's going to be y equals to 2 over x squared. So now they expect you to know the shape of the graph. They doesn't expect you obviously to solve this, but they do expect you to know the shape of the graph. So this is important. So this is going to be the shape of this graph. Okay, now if I have y equals to k over x. Okay, so the shape of the graph is going to be somewhat like this. Now this and this. All right, so this is very important. Now if I have y equals to some value of k. Okay, let's say for example if I have y equals to 3, that means I will have a horizontal straight line. Okay, I will have a horizontal straight line at this point where it says on the y-axis 3. Okay, so I'm gonna have a horizontal line over here. So this is what we mean when we say y equals to 3, right? And then this is the type of straight line that we've just talked about. So it's a linear equation graph, right? And this is now a quadratic equation graph, right? So if the value of k is positive, if the value of k is positive, it's going to be an smiley face graph. If the value of k is negative, and this is only with respect to this, okay, if the value of k is negative, the graph is going to be a sad face graph, right? So these are the differences, right? So I hope this is understood. And now when we have x cubed, so except for this and this, nothing is gonna come to plot. Okay, you're just gonna need to identify by looking at the shape of the graph. You're gonna need to identify which equation does it match to. All right, they're gonna give you a pool of equations, so you're gonna have to match the correct equation with the correct graph. So that's the pretty easy. For that, you just need to know the shape of the graph. So that is why I'm introducing you to this. Okay, so just take a screenshot while I'm doing down. All right, so it's important. Now what about cubic equation? If I have anything, let's say 3x cube, okay, so the graph is going to be somewhat like this, like this. Okay, right? And now if I have any variable to the power x, okay, let's say y equals to 5 to the power x, so this is going to be like this. Okay, and now if I have a graph of logs, so y equals to lgx, doesn't matter what the value of x is, it's gonna be this shape like this. Okay, so that's pretty much it. Okay, I hope that this is clear to you. If you have any question, then feel free to ask me in the comment. Perfect, so no questions as of yet. So is there anything that you guys did not understand? Okay, so now I'm gonna move these. Are all of these functions clear? Like the graph of these functions clear? So I'm gonna slowly move down this slide so that you could take a screenshot of each one of the graphs. Is that understood? Because this is gonna be one of the questions in your exams. So just practice in your factorization and it will get better. um Okay, so this is pretty much it for this topic. All right, so now we've officially finished the topic for algebra, right? And now I'm going to start off with another topic, which is geometry. So from this week onwards, we're going to be starting off with the topic of geometry. Okay, so there are a couple of things that we're going to study in geometry. So let's just get started with that. Let's just get familiarized with that. So in till now, if you have any queries, feel free to ask me with respect to algebra. If you have any queries, anything that you found difficult, um, anything that you had difficulty in understanding, this is your time. Feel free to ask me, right? So I'm gonna give you guys a brief about what we're gonna learn in this topic. All right, so in this topic, first and foremost, geometry is not possible without one thing, which is learning about the properties and shapes of um, properties of shapes, different type of shapes, right? So this topic is called, in other words, in past papers or in some topics, it's called mensuration. Okay, so this is a very important topic, right? With respect to, here we're gonna also find out areas and parameters, stuff like that, okay, of different shapes, whether it be 3D shapes. I'm gonna define you the difference between what's area, what's surface area, and then what's parameter. And for 2D space, 2D shapes, what exactly can the examiner ask you? All right, what are the limitations of the examiner? So we're going to discuss all of that as well. Now, with respect to geometry, we're going to also study of lines, angles, and polygons. All right, so we're gonna study of the difference between different type of lines and how they are drawn, and the type of angles between them. So there are majorly three different type of lines. So um, and what are the properties of those lines, right? So pretty much that, right? And then there's gonna be a well-known part, which is a Pythagoras theorem. So Pythagoras theorem, I think, is one of the major parts of one of the major parts when it comes to geometry. Now, Allah, if we have done Pythagoras theorem, we're gonna move on to trigonometry, right? So I'm pretty sure that you guys, you all of you are pretty familiar with trigonometry as well. Now, the last topic of this section would be transformation. So I hope this sums up everything that's included in geometry, right? So I'm gonna start off from here, or maybe let's just start off from Pythagoras theorem. Okay, so if we start off from Pythagoras theorem, because in properties of shapes in 2D and 3D shapes, Pythagoras theorem is gonna play a big role. Okay, so let's start from Pythagoras theorem. I'm gonna give you a little bit. So I think we have about 10 minutes and we have enough time to get it started. Okay, so regarding the previous topic, if you guys have any issues, anything that you did not understand, feel free to ask me right now. Okay, so now let's start off with Pythagoras theorem, right? So what's Pythagoras theorem? Does anybody understand this? If you guys know, then please comment down what does a Pythagoras theorem states, and where does it apply to. So comment down in the chat below. If you guys know what Pythagoras theorem means, comment that down in the chat below. Faster finger, guys. If you get it right, obviously I'm gonna call out your name as well. So kindly comment down in the chat what's a Pythagoras theorem. All right. So a Pythagoras theorem. Now let's first discuss to where it is actually applied to. Okay. So Pythagoras theorem is applied to, let me just give you guys some hints. Okay, so for triangles to figuring out the longest side. Okay, so That's great. Somebody actually answered it, right? So it's partially correct, not exactly correct, but yeah, it doesn't necessarily have to be, about calculating the longest side. It's just um, so that we can calculate any side of the triangle. And which triangle? So there's a specific triangle which it can be applied to. So only the right angle triangle it can be applied to. Okay, so what's a right angle triangle? Right angle triangle is a triangle at which one angle of this whole triangle is 90 degrees. Okay, so the side opposite to this angle is called hypotenuse, right? The side which is at the base of it, it's called base, obviously. And the side which forms the height of the triangle is called perpendicular. Okay, so these are the three names. So a scientist was named Pythagoras. He came up with a pretty simple solution to incorporate all of these equations, all of these sides. So he came up with a conclusive equation. So let's say hypotenuse is our A, base is our B, and perpendicular is our C. Okay, so he came up with an equation where he said hypotenuse squared is equals to the square, the sum of square of both the other sides, the sum of square of both the other sides. So this is essentially what the Pythagoras theorem states. So I think, yeah, somebody answered it. They said that it was about calculating the longest side, but it doesn't necessarily have to be about calculating the longest side. It can be used to calculate either of the sides. Okay, do you understand this? Is there anyone who doesn't understand this, or is there anyone who's learning this for the first time? So is this clear to all of you? If there's any question, then feel free to ask me right now. Right, so let's do a quick question before we come to a conclusion for this class, right? So let's consider this question for a second. Okay, so now we have a right angle triangle, right? Right angle triangle is right at this point. Okay, now what do we have to find? Do we have to find out the base, or do we have to find out the height? This side would be the base, this side would be the highest, and this side would be the hypotenuse, right? So what are we going to do? We are going to incorporate the Pythagoras theorem. So right, we hypotenuse square is equals to perpendicular square plus base square, right? Plus base square, right? So what's the value of perpendicular? Perpendicular is 20, sorry, perpendicular is 10. 10 squared plus 24 squared, right? And then we have hypotenuse squared, right? We need to find out its value. So now we're going to calculate this. So 100 squared, come on, quickly solve this equation. Whoever gets it first, quickly do it. So 100 squared is what? Can anyone tell me? It's 10 squared is 100 plus 24 squared is what? 576, right? So 576. Now if we add them both, it's going to become what? It's going to become 676, right? And now what we're going to do is we're going to take square root on both of the side, because we have to cancel out this square, right? So taking square root on both of the sides is going to cancel out with the square over here. So it's going to be hypotenuse equals to hypotenuse equals to um, right? 676 is going to be root 676 is equals to 26, right? So our hypotenuse is 26. And an amazing fun fact is that because this is the largest angle of these three angles, right, the length opposite to it, which is hypotenuse, would also be the longest side of the triangle, right? So this is very important. This would also be the longest side of triangle. So now if I have a question like this, okay, so this side is 5 and now this side is 3. Now to find out what's the value of the height, so how do I do this? So 5 square equals to 3 square plus x square, right? So 5 square is what? 5 square is 25, right? 5 squared is what? 25 minus 3 square, because it's going to move to that side. So 3 square is 9 equals to x square, right? So x square equals to 16. 25 minus 9 is 16, right? So now let's take a square root on both of the sides, right? It's going to cancel out with the square. We're going to left with perpendicular. Why the addition is equals to perpendicular square. Okay, so this is why it's called a theorem. Okay, so this is why it's called the theorem, because it's said to be proven, right? Because this is the longest side, and nothing, not any of these angles can be equal to this angle, right? Because this is 90 and the sum of angles is called 180. So there's a long theorem about it regarding angles and the sides. So if you want me to go into detail, which is not a part of your syllabus, so I can go into that, but it would be more difficult for you to understand. So just it'd be great if you could just follow this theorem and get familiarized with the answers. So yeah, somebody answered it correctly, which the value of it is root 16, which is 4. So x equals to 4, right? Because now getting back to the question, this is the longest side. This is 90-degree, and the sum of these three angles is going to be 180. So there's no other angle which is going to be greater than 90, right? So this sets this longest side apart, right? So we've devised a formulated way which says that the longest side when squared is always greater than is always equals to the sum of both of the other sides. Okay, so that is what the theorem is. Now regarding the value of x, so see, like I told you, it's not necessarily used to find out the value of the longest side, right, or the hypotenuse. It could be used to find out any value in a right angle triangle, right? I hope this is the first topic for the geometry is understood. And now I've gone over some of the topics that we're going to learn in the future as well. So starting off from this was pretty easy topic, so now we're done with this. We're going to do a couple of more questions on Friday, and then we're going to slightly shift off to properties of shapes, 2D and 3D figures both, right? So we're going to have a class on Friday, hopefully. All right. So till then, take care of yourself. All right. And keep practicing whatever's been taught today regarding functions, regarding Pythagoras theorem. Practice it so that you'll get better. All right. Take care. That's it for today. And if you guys have any questions, feel free to ask me right now. So thank you all for joining us. That's it for today.